Thank you, Professor Boyer, for the kind, the preface that you said for the theme. I am Shashank. I am from Terry. This presentation takes insights from what Professor Bohr and Mr. Reddy had mentioned in their presentations, and that is the key focus on localized consumption of power, when there is a lot of penetration of localized generation. So this research study we did in collaboration with a researcher from the Tokyo Institute of Technology, and henceforth our name has been mentioned here. Peer-to-peer trading of solar energy, and that too from rooftop solar systems. We'll be giving you a holistic view of the global practices that are being followed and some of the pioneering efforts in India that have taken place. Well, each one of us is quite familiar with this preface as to how the paradigm is dynamically shifting from centralized to more decentralized. And of course, the actors are rooftop solar photovoltaics, and now more of electric vehicles, demand response, energy storage, as Mr. Ranjan was mentioning, and wind power. Although we do not see something known as rooftop-based wind power, but then in certain pockets in Texas and even in Germany, I believe, Professor Bauer, wind power is an essential component. Well, this presentation is more focused towards how localized consumption of power generated locally amongst a set of consumers can actually help the distribution network in a stabilized operation. So this has got more to do with trading of power amongst each other, which has both financial and technical implications. And I'd really like to acknowledge our utility partners, BSES Rajdhani Power Limited, Mr. Ranjan is here, who actually helped us give insights into what can be the possible implications if one has to try this out here in India. So I must acknowledge Mr. Ranjan, Mr. Naveen is also here from the BSES Rajdhani Power Limited, who actually gave us sort of more confidence into modeling such studies. So as you can see, what I mean by peer-to-peer energy trading is more of localized power flows. So imagine a set of consumers within a vicinity of few meters from each other. What you rather would expect is the localized generation is being unpaid for or underpaid for, beg your pardon, because of the existing mechanisms of net metering and feed-in tariff. So what actually happens is you produce your own localized power, and by the laws of flow of active power, which on a small distribution network is limited by the R by X ratio, which is particularly higher for distribution network, you are supposed to have your electrons or active power being more dependent on the voltage magnitude difference. Point cut short, your excess power is going into your neighbor's house most probably, but what you get in return is the tariff that has been set by the regulator, and what the neighboring consumer, who accidentally doesn't know that he has consumed your electrons, has to pay the extra, I mean, in terms of the actual worth of solar power that he has consumed. Now, what we propose in this presentation or this study is, there is a competitive advantage for innovation in such a retail segment, an increasing paradigm or evolving paradigm of localized electricity markets or energy markets. So if I just skip on, and if I push the mouse button, you certainly get to see a block which is known as a blockchain. Now, how digitalization, localized energy power flows, rooftop solar systems, how they will stitch together well to sort of ease distribution system operation and provide the true benefits of clean power to each one of the prosumer or the consumer or even the distribution network operator. We'll touch upon a few of the points, but I have to set the premise. The existing compensation is in terms of a net metering arrangement, And as Mr. Ranjan mentioned, they have a lot of penetration of localized solar photovoltaic systems. They are rooftop based, mostly residential, but you see the trend. More of industrial consumers are going for such systems because of the tariff structure in the country. But the point is, you get billed at at the end of your month. So what you are actually getting is a reduction in the energy units, since you sort of produce more and put it back to the grid, and that is accounted for at the end of the month. Whereas in the new paradigm that we are sort of proposing of, you get instant settlements for whatever you produce, and you have the say to bid for the price. So you can enter actually into an agreement with your neighbor, but how will that happen? Will it be intraday? Will it be intra-block? That is one thing that has to be studied. This presentation just makes an effort to apprise each one of us of what are the pioneering efforts in this country as well. I have listed a few points in favor of the distribution company, the DISCOM, and I think Mr. Ranjan would also agree with me. When you have a lot of localized generation, you're actually consuming within a more localized boundary of the distribution transformer. So the distribution company does not have to actually procure more costly power during peak periods, because it sort of balances or settles the localized power flows. So that's what it says, the demand gets completed locally. Plus, the distribution company also is compensated for by providing a service charge for each transaction. As for the peers, or who are the ones actually taking part in such an exercise, well, they can trade within the community. They can, with a tongue-in-cheek, if I can say, have cheaper prices than a retail tariff, but that has to be worked on. The biggest thing is, what I feel and what my group of researchers feel at TERI is, there is always a cost associated with the transaction. And all the businesses are actually converging towards bringing sort of transparency and reduction in such costs of each transaction. So an instant settlement, an instant payment to the renewable energy producer, which in this case is a rooftop solar owner, is one of the advantages of such a pricing, of such a trading mechanism. And the technical implications of course follow as well, since Mr. Ranjan also mentioned, there is always a chance of reverse flow of powers, but if you can have it localized, if you can have it consumed localized, then you can actually prevent your network upstream the distribution transformer to face such power flows. But this particular presentation is actually focusing towards how to compensate for the localized consumption of power, because electrons will somehow find their way out. It's just energy accounting in the end. And accounting is being proposed, and you can see the cash flow as well, is being proposed by the use of something known as blockchain. If you focus on this particular graphic, so you have cash flow and you have physical infrastructure. So the evolving paradigm is distribution network operators somehow act as highway operators, and each passing electron pays a toll tax. It's kind of an evolving mechanism which is expected to come out with more and more of localized generation and consumption. So there's something known as a market clearing price, where you and me, or a set of consumers like all of us who are owning rooftop systems, and ones who do not even own, those who do not even own but are in your vicinity, enter into an agreement and clear their bids. But of course with the consent of the distribution of the regulator and the pricing mechanisms that have to be sorted out. This looks to be a very tedious graphic. The point cut short is, you have to enforce trust in each and every transaction. The only point here is, whenever you have a transaction between two peers or a set of peers, you have a lot of cost involved into the same. Plus, you might not trust the other party. When you operate on such transaction through a centralized database, which is actually managing all the ledger entries, you are vulnerable to cyber threats. Blockchain is just a chain of nodes wherein each one of the participant in such a mechanism holds a stake in the same. So everyone knows everything, but no one owns it. And that's how the ledger becomes distributed. Henceforth, this is also known as distributed ledger technology. And the backbone of such a technology is known as smart contracts. And we at Terry have also programmed a similar smart contract which essentially takes care of all the settlements, all the transactions. It acts like a mini market mechanism with all your price bids being evaluated, all your price bids being arranged in the order of magnitude, and all the settlements being executed. So as I said, and you must also be quite aware and even fascinated by the term which was coined by the original developer of blockchain, and that is Bitcoin. So these are just energy tokens which are virtual currency or cryptocurrency. And as we just discussed, a smart contract is a set of rules, a set of algorithms which will get activated every time you have a price bid from the peer who's trying to sell or the peer who's trying to buy. So we at Terry have actually run a sample exercise on a sample data set, and we have tried to find out the feasibility of such a mechanism if that was to happen in the country, because one of the regulators in the country has actually mentioned in its regulation for the use of blockchain, but how and what exactly would be the usage has not been mentioned. We aim to show this pilot or this prototype to the relevant stakeholders. So, as mentioned, each peer-to-peer transaction in a localized electricity market will have 3 steps. You have got to give your bids, the selling bids, the buying bids, and then of course you have an auctioning mechanism wherein you clear your prices, and then you have to evaluate your metrics. What that bidding strategy will it be using rules of game theory? Will it be using artificial intelligence, but that requires a lot of data? I can relate very well since my PhD was in predictive analytics. It requires a lot of data, and distribution sector data is quite difficult to obtain. We'll skip through these slides because these are too theoretical in content, and also because the reason that we have not used any of them in a study. Perhaps what we have used is something which is much more simpler instead of going into academic jargons. So I'll share the presentation with you. You can go through the same, but the point is each one of the peer in our prototype is actually getting all the green credits, even though he is a small system owner. Because the problem with the earlier stated techniques was you might actually lose the race, and then you might feel that I'm not being able to get a bid at all. So since these are the nascent stages, we at Terry have thought that, let's not go with the academic jargon, let's make something which is more inclusive, and hence our aim is to scale up the adoption of rooftop systems, and particularly in the residential sector. So we are taking a unit of energy equals 1 digital token. And these are some of the policy recommendations that we hope to come out with once we do, a more comprehensive demonstration of the prototype that we have developed at Terry, and which is what we call as the proof of concept. So we are still proofing the concept, but we are very sure that this seems to be an interesting proposition. And we have the likes of BSES with us who are actually also trying to give us more insights. And I must acknowledge that Mr. Ranjan had also apprised me of possible benefits to the distribution company because of rooftop solar and scaling up to the same by peer-to-peer trading. Well, thank you so much.